Open ditches. A ditch that will safely convey the required stream should be selected. In designing a permanent ditch, a profile of the center line showing the location and elevation of the water supply and any required turnouts, crossings, drainage bypasses, and the like is required. The water level at field turnout points must be high enough to provide the required flow onto the field surface. The water level required varies with the type of takeout structures, but the head should be at least 10 centimeters, which is about 4 inches. Structures. In the selection of a specific structure, the depth of flow D should always equal the depth of flow in the ditch, and the structure capacity should equal or exceed the design flow capacity of the ditch. Standard structures should be used wherever possible. If a special design is required, the job should be designed in cooperation with someone having the authority to approve it. In most instances, it is desirable to exceed minimum requirements to provide longer life, better operation, or easier construction. Whenever possible, the farmers and contractors should be encouraged to utilize the standard plans already available. Drops. Drops are placed in a ditch or canal to hold the velocity of flow within allowable limits, to increase the head on turnout devices, or both. Velocity limitations for irrigation, ditch, and canal standards are described in the technical guide. Drop structures should be placed so that, if needed, they can be used to divert water onto the land. A good rule to use for the location is to place the structure about 3 or 4.6 meters, which corresponds to 10 or 15 feet downstream from the point where the water level is 0.15 meters, which is equivalent to half foot, above the graded land surface. This procedure appears to place the structures on fill. However, since the line represents the water level and not the ditch bottom, the structure will always be on firm ground. The height of drop structures used to lower water from one control point to another should be based on the economics involved and the desires of the farmer. Since 2 smaller drops take more material and labor than one larger structure, the tendency in newly irrigated areas is to use fewer, higher drops than to keep the cost down. In many of the older irrigated areas, the tendency is to use more small drops to eliminate deep ditches between structures. For small farm ditches, the height of the drop in meters should not exceed 0.3 times the land slope in percentage. A drop of more than 1 meter, that is about 3 feet, high should seldom be used. With large streams, this height is sometimes increased. On steep slopes, it is often advisable to use a concrete lined ditch section or pipeline to lower the water. Turnouts should be placed so that it is not necessary to check the water above the design flow of the ditch, thereby providing a safety factor if water is turned down the ditch with the check flashboard still in place. Crossings should be provided so that equipment will have access to all parts of the field. With pipe drop structures, a crossing can be provided by extending the length of the barrel and increasing the width of the fill. Pipelines. Irrigation pipelines can be used for the same purposes as open channels or in place of open channels. Because the pipelines almost eliminate losses from evaporation and seepage, water distribution efficiency is high. They are particularly adapted to areas where seepage losses from ditches are high. Pipelines have an advantage over open ditches, where it is difficult to excavate and where it is necessary to carry water down steep slopes. Buried pipelines do not require as much land as ditches. Therefore, the land can be used for other purposes. Pipelines require careful planning for correct location, capacity requirements, proper selection of materials, and construction methods. Measuring devices. Measuring devices are needed so that the farmer knows how much water he or she is using and can make the necessary adjustments for efficiency. The simplest of all measuring devices is a weir, but it requires a loss of head to function accurately. When such a head loss cannot be tolerated, a partial flume or trapezoidal flume may be used. Many large ditch companies have measuring devices built into the head gates. Some pumping installations are equipped with flow meters on the discharge line. Appropriate measuring devices should be considered as essential items for good irrigation water management. For more efficient application of irrigation water by surface methods, it is often necessary to modify the topography. Such modification, made according to a plan providing for specific elevations at each point, is called land leveling. The ideal land surface for surface irrigation has little or no cross slope and has a uniform downfield slope that is slight enough that erosion from rainfall and irrigation water is not a problem, and adequate enough to provide good surface drainage. If the conditions are appropriate, the ideal land surface is flat in both directions. The slope limitations vary from location to location because of differences in soil and rainfall. Some fields are ideal, requiring no leveling. Generally, however, it is necessary to do some leveling on each field. Standards for satisfactory leveling have risen over the years, and farmers are deciding that it's worthwhile to re-level some fields. Water disposal system. A complete water disposal system should be planned for each irrigated farm. This disposal system should be able to convey storm and irrigation runoff to an outlet without causing excessive erosion. It should be incorporated as part of the drainage design on lands that require or have a subsurface drainage system. On lands that require only surface water disposal, the drainage system should be built at the same time the lands are leveled, if possible. In many cases, the disposal system will use waterways designed principally to carry storm runoff. If irrigation tailwater is to enter these waterways, special plantings and maintenance often must be specified. In addition to sprinkle systems, the farmer has a wide choice of portable irrigation equipment. This portable equipment has been developed to permit more accurate distribution of water and to reduce labor requirements. Check dams. Several types of canvas, plastic, and metal check dams are available for both lined and unlined ditches. These check dams are designed to block the flow in a ditch just below the point where the water is to be turned out. They can be placed at any location and are not in the way when a ditch needs to be cleaned or rebuilt. Most check dams are adjustable so that the water can be held at some constant level. Siphon tubes. Siphon tubes are widely used to withdraw water from an irrigation ditch. They range from 1 centimeter, that is about 0.4 inches in diameter, to large fabricated siphons that carry as much as 57 liters per second, which is also 15 gallons per second. The small tubes usually are used for furrow irrigation, although a number of them may be used together for border or contour ditch irrigation. For furrow irrigation, the tube sizes usually are selected so that 2 or 3 tubes per furrow will deliver the maximum stream recommended for the slope being irrigated. After the water has crossed the field, 1 tube is removed to provide the cutback stream. Hydraulic head is the difference in height between the supply ditch and the center line of the discharge end of the tube, or the water level in the furrow when the discharge end is submerged. Gated pipe. Gated pipe is made of lightweight metal or plastic and has small gates or openings spaced to match the furrows. The pipe comes in sections that are easy for one person to handle and is fitted with simple watertight connections. A slightly different product made of vinyl-coated glass, cloth, butyl, plastic, or canvas hose and equipped with small outlets can be used for the same purpose. Gated pipe reduces water losses during conveyance and provides a positive control of the water to each individual furrow. Operating heads of more than 0.6 meters or 2 feet usually require socks on the openings to avoid erosion. Some head is required at the last gate to produce flow through the gate. The head required depends on the type of gate used and the desired flow. Usually the head is less than 0.3 meters or 1 foot.